Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and today we're going to discuss the difference between a counterflow and a parallel flow water coil. The two most common flow arrangements in a water coil are counterflow and parallel flow. In a counterflow coil, the direction of the water flow is opposite or counter to the airflow. So it looks something like this. So let's draw a coil. The bottom is the supply, the top is the return, and so our water flow will go in this direction, into the supply and out the return. And then we'll draw our airflow in, and our airflow is going in the opposite direction of the water flow, so it's going this way through the coil. So if this was a hot water coil on a VAV box, the cold supply air coming in would see the coldest water temperature first, and then as the air moved through the coil, it would move towards the warmer temperature water. In a parallel flow coil, the airflow and water flow are running in the same direction. So it looks like this. Let's draw our coil again. Now we're going to have our supply here and our return here, and the water is moving from the supply to the return in this direction, and then the airflow is moving in the same direction. In a parallel flow coil, the cold supply air will see the warmest water temperatures first, and then as it moves through the coil, the water temperatures will go down. So let me make a little more room. So one potential issue with parallel flow coils is the large temperature differential between the air and water temperatures. This can cause thermal stress on the material in the coil, and that could result in material failures over time. The temperature profile of a counterflow water coil looks something like this. So the supply air is moving in this direction and the temperature is increasing as it goes across the coil. The water flow is moving the opposite direction, so it starts warm and the temperature drops as the heat is transferred to the airflow. The temperature differential between air and water are fairly uniform. This reduces the stress on the material in the coil. Plus, the discharge temperature of the air can be close to the inlet temperature of the water. The temperature profile of a parallel flow coil looks something like this. So the airflow comes in and warms up as it passes through the water coil, and the water temperature is reduced as heat is transferred to the airstream. But since they're both moving in the same direction, you can see there's a higher temperature gradient at the beginning of the coil than at the end of the coil. And this large temperature gradient can cause thermal stress in the material of the coil and potentially failures in the future. Parallel flow coils are good if you're trying to bring the air and water temperatures to nearly the same temperature. But counterflow coils are typically more efficient at heat transfer than parallel flow coils are. So that's the difference between counterflow and parallel flow water coils. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.